Hi, and welcome back. I'm Hank Preston, a developer evangelist with Cisco DevNet, and today I'd like to talk to you about configuration management and the network. This is a lesson in our Network Programmability Basics video course, and we are inside of the NetDevOps module and just getting started. In this lesson, we will discuss where does configuration management fit into the network, and then we'll spend 3 lessons on Ansible showing you how you can get started using these tools in your NetDevOps concepts. If you'd like to follow along with me, I encourage it. You can go on up to GitHub at github.com/cisco-devnet/netprog_basics. From there, you can access all of the code for all of the labs. We've got READMEs that detail how you can set up your own workstation to follow along, as well as all the code samples we'll go through. And you'll have details on which DevNet sandboxes to go ahead and access and leverage so that you can work through all of these exercises. Now in this lesson, we're going to answer these 3 bullet points. First, what exactly is configuration management? And then the benefits that configuration management bring to organizations. And then we'll end with a quick discussion about some of the most common tools that you may be hearing about and thinking about leveraging in your own environments. So, what exactly is configuration management? Well, definitions by Hank. I call configuration management a mechanism for maintaining the characteristics of a system. So what are these components? Let's dive in, starting with mechanism. Mechanism in configuration management is all about automation. We're trying to get away from this hand-to-hand combat of one engineer to one device, one system, or one network appliance to bring that online and maintain its configuration. We're all about the tools in CM because we're targeting to try to add consistency plus scale so that we can have wide success inside of our systems. Now the characteristics are where we're describing the desired state or our intent inside of our network. Our characteristics can include things like the software and version installed inside of the systems, attributes like name, address, ownership, all of the details about an individual system, and then all of the feature-specific configurations. So in the network, if we're deploying HSRP, what are the HSRP configurations system by system? What are your routing protocols? Which area, which protocols are you using? Which network should be advertised through the system? Those are the characteristics. And using the CM tools, these characteristics plus the mechanism through automation, we push this out in a consistent fashion across the environment. The benefits are many that come to configuration management, but I want to talk about 3 specific ones that you can see and expect to go for. So we'll start with quickly provisioning infrastructure. Today, most of us have a sequential and manual process for provisioning infrastructure, whether it's day 0 or updates down the road. We have one engineer or a few engineers and they tackle one system and then move to the next one, on and on until they get to the end. With configuration management, the goal here is to have parallel and automated deployment of all of our infrastructure provisioning. So when we kick off our routines, the configuration management system can go ahead and tackle the entire environment simultaneously, making it much faster to provision that infrastructure. Secondly, no more snowflakes. So snowflakes in this case is a bad thing. We don't want system variation across the board, which is what many of us have today. Whether we're talking about servers or network infrastructure, each one has a bit of variation depending on exactly when it was deployed, which engineer deployed it, and how they actually followed the process to get it configured. With configuration management systems, by combining the automation with the characteristics and the desired state, we end up with consistency across the entire system, so those snowflakes go away. And then related to that, we get into version-controlled infrastructure. Because the configuration management tools in this space that are being developed can treat those infrastructure configurations as code, we can get away from this organic configuration where we have to combine the current state on particular devices with maybe information from spreadsheets or notes that people have taken, and we're not exactly sure what's out there inside of our infrastructure versioning. We want to move to infrastructure as code, where we can take our infrastructure configuration descriptions using these configuration management utilities, store them in code repositories, and leverage features like branches and merging, commit structures, pull requests, issue logs, so that we can treat that infrastructure as code element as the single source of truth and we know what our infrastructure is programmed to be. Now, recipes, manifests, playbooks, oh my. Configuration management is really all about the tools, and there are a lot of them, and new ones being developed every day. Now, there are some commonalities across the configuration management tools that you may run across. Each tool is about automation and orchestration. Now, these are different things in my perspective. Automation is how I can automatically take some action against a system. I want to configure an interface, or I want to deploy a VLAN. Orchestration is a structure on how we can actually describe how all of those automated activities need to happen. The order they have to happen, things that have to happen before or complete. That's all about automation plus orchestration, and each of these tools have mechanisms to apply that. Then we have idempotent behavior, a very difficult word to say, but it's a concept that we want in this area. This means that when we deploy a configuration using configuration management tools, we should feel comfortable and safe rerunning these configurations against the system, because these tools target checking to see what the current state of a configuration is before changing it. So they just don't automatically rerun configuration after configuration on a device, something that could be impacting to the environment. If the configuration already meets with the desired state, it moves on and lets that system stay put. Then we have facts, lots of facts. Because we're doing automation across a range of systems, servers, networks, compute infrastructure, we need to be able to understand which system is currently being configured and then reflect that in its configuration. Each of these tools have a way to gather information about the systems under the hood. So in the network space, when we start a process, the particular configuration management tool can query the device and learn things like its host name, its serial number, the version of software that it's currently on, and then we can use all of those characteristics within our orchestration and automation tool sets to take action based on what we find out. Next, modules and libraries. These are not simply scripting languages that you're using. Each of these tools come bundled together with modules that know how to take particular actions. I call them atomic actions against an infrastructure component. So in our network space, we have modules that know how to create VLANs, or how to manipulate routing infrastructure, or maybe even deploy using protocols like netconf, using Yang data models. So we don't have to write the raw code for those inside of a scripting language. Each of these tools will come with modules that we can just leverage and provide the inputs necessary. And then finally, they all have an open source foundation. Though each one of these tools, Puppet, Chef, Ansible, and Salt, all provide enterprise-grade options that include potentially additional feature set, support, training possibilities, they all come with an open source area, which means they're very quick and inexpensive to test out, so that you can try each one of them until you figure out which one meets your needs the best. Now, if we look at some of the common terms and information across these tools to help you figure out which one might make the most sense for your environment, I called out a couple of different characteristics and show where they fit in. So for example, the underlying language that's used is between Ruby, which is leveraged in both Puppet and Chef, and then Ansible and Salt Stack use Python underneath the hood. Now, a big important one, particularly in this network, is this managed node requirement. Other than Ansible, they all are typically agent-based. Now, Puppet does offer an agentless solution that they're going through, but the most common use of Puppet today requires agents or software running on the managed nodes. Ansible, on the other hand, doesn't require any of that, and you can leverage it without having to provide anything specific on the edge nodes to go through. From a centralized management, you'll hear terms like Puppet Master referred to Puppet, which is that centralized control point. The Chef server or the Salt Master provide those capabilities for those tools. Now with Ansible, any computer can be the controller, though with some of the enterprise solutions, you can run into some centralized capabilities as well. And then finally are the script names or the module names that we're going to leverage. With Puppet, we have manifests and modules. In Ansible, we've got playbook and roles. Chef offers us recipes and cookbooks. And so, with Salt, we have pillars and then includes that bring together these components that go through. Now in this module, or in the rest of this module inside of the Network Programmability video course, we are going to focus on starting with Ansible. So the reason we're looking at Ansible as a great entry point is because as an agentless tool, it makes it very easy to work with network elements, so we don't have a requirement of being able to or needing to install software at the edge. It's also very popular currently in the networking community, which means there are tons of examples that you can leverage to get started. Because we're spending a lot of time in Python already in network automation, the fact that Ansible is written in Python is an extra bonus. And it's also very simple and easy to get started with. Now, though we are looking at Ansible inside of these lessons, be sure to explore the other options that are out there. Your organization and your enterprise may already be using Puppet, Chef, or Salt for other areas, so it would be good to explore those solutions as well it's not always necessary to bring in another tool into your environment. So in summary, this was just getting us started. We've defined exactly what is meant by configuration management and explored some of the benefits that these tools and strategies bring to our organizations. We introduced some of the common tools and the capabilities that are consistent across the tools and discussed some of the ones that you may see floating around in the ecosystems that are out there. Now be sure to stick around and complete the entire Network Programmability Basics course, particularly the next 3 lessons in this module, where we look at how we can use Ansible against the network. Run all the exercises and examples yourself that you'll find in the code repository, and then join DevNet for more information with learning labs and sandboxes. If you have any questions while you're going through, feel free to come find me directly. You can reach me on email or Cisco Spark at hapresto@cisco.com or on Twitter at hfpreston. And I'm up on GitHub at hpreston. Cisco DevNet is who you can look for on Twitter, Facebook, and GitHub to stay tuned with everything that is going on within the DevNet organization. Thanks so much for joining me for this lesson. I'll see you in the next one where we'll dive specifically into Ansible for network configuration management. Thank you.